Okay guys, here we go. Section 1.2. Okay, we're going to start talking about limits. Limits is a big part of calculus. Okay, we'll be spending some time on limits. Spending a lot of time on limits. Well, chapter 1 all talks about limits, hopefully setting you up for success in your futures. Okay, so 1.2 talks about finding limits graphically and numeric. Okay, there's going to be three ways that we solve or find, I don't want to say solve, where we find limits. Okay, and one of them is graphically, which is what it looks like using a graph. One of them is numerically, which means looking at tables. And the third one is analytically, and we'll cover that in section 1.3. Okay, so suppose you are asked to graph f of x equals x cubed minus 1 over x minus 1, where x doesn't equal 1. Okay? So let's suppose you were asked to graph this. So if you were going to graph this, one thing you might want to do is you might want to look at the intercepts. Okay, you might want to look at the intercepts. So let's talk about the intercepts. So if I plug a 0 in for x, okay, I plug a 0 in here, and I get on the top -1. I plug a 0 in here. On the bottom, I get -1. So it looks like I get 0, 1 for my x-intercept. And we want to find, that's my y-intercept, right? Y-intercept. Okay, now I want to find my x-intercept. And that means I'm going to plug a 0 in for y. So when you plug a 0 in for y, that's what y is, f of x, another way of saying y. So if I let x cubed minus 1 over x minus 1 equals 0, well, in order for a fraction to equal 0, what has to happen is we have to have our numerator equal 0. Okay, so I need to make x cubed minus 1 equal to 0. So you might look at that, and say, okay, well, let's add 1 and add 1. And I get x cubed equals 1, and we take the cube root of x and the cube root of x, and x equals 1. So x equals 1 is a root, okay? It is a root. However, when I think of x cubed minus 1, okay, I think there's more to that, okay? There's more to x cubed minus 1. Because if I had x cubed minus 1, I could factor that. Okay, I could factor that. So these are both cubes. So the pattern is we take the cube root of my first term and the cube root of my second term. And then I take this and square it. The opposite of this times this. That's squared. Okay, if that is foreign to you, make sure you speak up to me in class, and I will explain it a little bit more. But in any event, here's where that x equals 1 shows up. However, there are other roots here. Okay, there are other roots at work there. Now, if I were to use the quadratic formula to solve this, I'm going to kind of cut to the chase here, save us some time, save you guys some writing. If I use my quadratic formula, use quadratic formula, I would find this. -1 plus or minus the square root of -3 all over 2. So what does that mean? It means we have imaginary answers, which means they're not going to show up in my graphs. Okay? So sometimes when we're exploring these functions and we're looking at them and we're trying to find solutions, sometimes the easy solution like this, there's more to it than meets the eye. Okay? So we're going to continue to think about this function, okay? And we're going to continue to explore it, to learn how to evaluate it, okay? gonna erase all this. Again, if you missed any of this, just go back. You guys have it on video, so that should be an easy thing to do. So let's say we had this, f of x equals, it's the same function we were just talking about, x cubed minus 1 over x minus 1. Okay, so let's say I wanted to find out what f of 2 was. Okay, we're still investigating, figuring out what this function is going to be like. So if I want to find out what f of 2 is, well, you can do that with your calculator. You know what? We're going to be pretty reliant. I don't want to say reliant. We're going to do it both ways, okay? Because when you go to college, I don't know if your professor is going to insist that you use the graphing calculator or insist that you can't use it, okay? I've had some students go to the same school, okay? They're taking the same course. They have different professors. One says, graphing calculator is awesome, use it. The other one says, what are you in here for? The only calculator you can use is a scientific calculator. So, you know, I don't know what your teachers are going to do, so I'm going to show you both ways. But it makes a lot of sense to use the graphing calculator. So, I'll pull it up on the screen here. So, I first have to type in the function. So I go to my y equals screen, and whenever you do a fraction, you have to have parentheses around your numerator. So this is going to be x cubed minus 1 end parenthesis divided by beginning parenthesis x minus 1 end parenthesis. And then I always hit graph. And as you can see, I've got a box and whisker in there. Okay, so I've got to get rid of that. I go to my second stat plot and I turn that off. And I go back to my graph, and I'm not going to get a great picture because the window, okay, the window was set for a box and whisker plot. So I go to my window. As you can see, it's kind of strange. I'm going to make this -10, 10 and 1. It's kind of a standard viewing window. I may have to change it. I don't have the magic formula for windows. I fiddle, okay? Fiddle with it. And there's my graph. And it's funny because when you look at that graph, it really looks just like a quadratic, okay? And I think you'll find that it is similar to a quadratic. But there are some changes that we'll talk about shortly. So if I want to find out what f of 2 was, get back to business here. F of 2, well, the way that we can do that is we can hit our second button. And we can hit the trace button. And it says value, hit enter for value, put a 2 in, and it gives us an answer. So I get 2, 7. And you can say, well, I could have done that a lot faster here. Yep, sometimes you can. Okay, sometimes you can't get it faster when you just plug it in. But I want to show you how to use a calculator. So when we plug in f of 2, we get 7. Okay, f of 2 is 7. And if you look at this function, we could learn a lot about this function by plugging in numbers, okay? But what would happen? What would happen if I plugged in a 1? What would happen if I plugged in a 1? Well, let's look. Let's look up here. I get a 1 minus 1 on the bottom, which means it's undefined. So I'm not going to get an answer there. So let's look. Let's see what the calculator does for that. So I hit my second calc for value and I type in 1, and there's no answer listed. There's no answer listed. So that tells me that something strange is happening there. Okay? That means that something strange is happening. Well, let's see what happens as we get close to 1. That's the whole idea of a limit. Okay, we're going to talk about that in a little bit. Let's see what happens when we get close to 1. So I could plug in a 1.2. I could. Okay, I could do that. So let's do that. Let's go back to the calculator. And let's type in second calc value 1.2, and you get 3.64. Interesting. Okay. Let's look at some more values that are close there. Let's look at one that's even closer. Let's do f of 1.0001. Okay, and then maybe we'll look at f of That's close to 1 on that side. Let's look at something close to 1 on the other side, something that's a little smaller. Okay, so I'm going to look at those two. Okay, I think you know how to do it with a calculator. It's going to be faster if I stand up here and do this. So I'm going to hit second calc value 1.0001, and I get 3.0003. 3.0003. So at 1.2 it was 3.64. At 1.0001 it was 3.003. Let's look at what happens on the other side. Let's look at what happens on the other side. So I'm going to hit second calc, and I'm going to hit value, and I'm going to type in 0.9999, and I get 2.9997. 2.9997. So if you look, they actually kind of show me on the graph for that one. They give you a little X on the graph. These, you guys might have a newer version. I tried to pass out the newest version calculators for everybody. So you can see it's right there. Okay, so if you look from this side, it looks like it's getting close to 3. From this side, it looks like it's getting close to 3. So that is using the graphical approach, okay? And what would happen here is, if we were to blow up this, okay, and you know what? I'm going to give this as a task for you. I'd love to see if you guys could figure out how to do this. I knew how to do it one time, but I forgot. If you were to, there's something that you could do to this graph, and what you would see is, you would see the graph as it gets close to my x value of 1 and the y value we think is going to be close to 3, there's actually a break in the graph and there's an open circle there. That's because when x is 1, it makes this undefined. Okay, it makes this function undefined. But it's hard to see, okay, because I think there's ways to blow this up. I don't know, there was a way, I knew at one point. It's not a huge thing, okay, it's not a huge thing. But it is something that if someone finds out, let me know, we'll do it together. So, that was the graphical approach, okay? Let's talk about, and graphical because we used a graph, right? We used a graph, we plugged in some values. This one's going to be called the numerical approach. Numerical approach. Okay? And so what we're going to do here is we're going to look, okay, at values that are getting close to 1. Okay, so we're going to use our graphing calculator to make a table. So pay attention to this. Okay, listen as I speak so you guys can write this down, because you're going to need to do this. You're going to need to create a table with your graph. Okay, so we're going to do, see where it says table set? So let me get out of here. Let me clear my graph. I'm going to hit second window for table set. And this says table start. So I think I'm going to start at 0.97 because I want to start at something that's going to be close to 1. Okay? Because I want to investigate what happens as x gets close to 1. So I put in 0.97. And this tells me what they want to go by. What's my interval for my table? So I'm going to make this 0.01. Okay? And let's look what happens. Let's hit second table. Here's our table. Here is our table, okay? So if you can look and see the table here, and you can do it on your own calculator, okay? You get a better picture that way. Okay, it says 0.97 is 2.91, 0.98, 2.94, 0.99, 2.97. 1 says error, 1.01, 3.03, 1.02, 3.06, 1.03, 3.0909. So this is what you would write down for your numerical approach. Okay, so up top here we have 0.97, 0.98, 0.99, 1, 1.01, 1.02, 1.03, and then we write our y values in. 2.9109, 2.9109, and then 2.9404, 2.9404, 2.9701, error. Okay, 3.0301, 3.0604, and 3.0909. Okay, so that is looking at it with what's called the numerical approach. Okay, the numerical approach is looking at a table. Okay, and I'm hoping that you wrote that down. And you wrote down the keys to get there, because you're going to need to know how to do that. So let's look at this function. Let's look at it a different way now. Okay? So the limit as x approaches 1 of my function, x cubed minus 1 over x minus 1. So we've done this two ways. On a quiz or a test, you'll probably only be asked to do the problems one way. Graphically, we looked at our graph, okay? From one side, as I approached from the x from this direction, which means my graph is here, it was approaching 3. From this graph, it was approaching 3. If I look at my numerical table, from here, my values are approaching 3. From here, my values are approaching 3. So we say the limit is equal to 3, okay, as x approaches 1. So that's what a limit is. The limit is the y value that the function is approaching, okay, for whatever x value they give you. That's what a limit is. And in order for this to be true, it has to approach the same value from both sides, okay? If going from this side it was approaching 3, and coming from this side it was approaching 4, then we would say the limit doesn't exist, okay? They have to approach the same y value, okay? So let's look at some more limits, and then we'll come back and talk about this one a little bit more. So this limit's going to be easier to look at, okay? And I'm going to put it up, and I want you guys to think about why this one would be easier. Okay, so the reason that this one, now think about it. What's the reason this one's easier? Take a look at it. Take a look at the function. The last one, okay, this one here, and I still have it up. This one here, if I tried to plug in this number, it would make it undefined. Do I have any problems if I plug this number in? No, I can plug that number in. I can just do this one by direct substitution, okay? Direct substitution. And the reason I can do it by direct substitution is because when I can plug the number, it doesn't cause any problems. So I'm going to have 2 squared plus 2. 2 squared is 4. 4 plus 2 is 6. So the limit of that function, as x approaches 2, 2 squared is 4. 4 plus 2 is 6. Okay? Let's say I had this one. The limit as x approaches 2. X squared minus 3x plus 2 over x minus 2. Okay? So, I want you guys to take that one, and I want you to do it numerically, okay? And then I want you to do it graphically. So, what you're going to have to do here is you're going to have to pause the video, okay? Type it in. This is good practice for you. It's one thing to see me do it. It's another thing for you to be able to do it by yourself. Okay, so please take that, plug it in, and